In this video, let us focus on some important results on equal chords. One of the results is equal chords of a circle are equidistant from the center. So let us try and see what is this. We have a circle, for example, and then say we have two chords which are equal. That's the most important thing here. We are talking about equal chords here. So say let us have a chord AB and say let's have a chord CD. Now, these equal chords are equidistant from the center. This is the center. So the distance from the center to the chord CD is going to be equal to the distance from the center to the chord AB. So that is what the first property is all about. Let me repeat the property. Equal chords of a circle are equidistant from the center. So let's take it O. Alright, the next property is nothing very different from the first one. It's just kind of the reverse of the first one. It says that the chords of a circle which are equidistant from the center are equal. Now let us look into the same figure from a different point. Now let's say the distance, now there is a circle and then there are two chords, and let us say now, say for example, let's name this E. The distance is OE is equal to the distance OF. If the distance OE is equal to the distance OF, then AB is equal to CD. So here, equal chords of a circle. If the chords are equal, then the distances from the center to the chords are equidistant. But the second property is, if the distances from the center to the chords are equidistant, then the chords are equal. Pretty simple that. Let us go to the next property now, which is a little different. The next property says that equal chords of congruent circles are equidistant from the corresponding centers. Now say for this, let us take two circles that are congruent to each other or equal to each other. Now, equal chords of congruent circles are equidistant from the corresponding centers. Now, say these two circles are equal in terms of radius, area, and all those things. And say we've got two chords and the two circles, which is of the same length. Say here AB is equal to CD. Then the distances of these chords from their respective centers of their circles are going to be equal. This has to be perpendicular. That is how you measure the distance. So this OE is going to be equal to OF. That is what happens when there are equal chords in congruent circles. Then their distances from the center are equidistant. Now let us go to the next property, which is again not going to be very different from the one that we just did. Now, this is again not very different from this. It's like kind of the reverse way of looking at this property. Chords of congruent circles which are equidistant from the corresponding centers are equal. Now the same two figures, let's look into it in a different way. Let us consider two chords, say which is AB and CD, and say their distances from the center are equal already. They are equal. Then the lengths of AB and CD are going to be equal. That is what the final property on this page says.